You can put a date on it, right? Because then it'll be under today's date if you ever want to look back. Today's the 27th. Okay. Given the graph, answer the following. Determine the equation. Remember this. Quadratics, you need at least 3 points. Right? For a quadratic, you can't. 2 won't do it. Like, in fact, if you try it, the calculator is going to complain. So we've got 2. The key here is to find the one right across one of the. If you have one on the arm, find the one across from it. Okay, using symmetry. So we actually know that this point, we know that the y value is going to be the same as that, right? So we just need to figure out the x value there. So you can use the axis of symmetry equation, right? Maybe I should do that here. So x equal to x1 plus x2, and I'll give you a shortcut in a bit. Okay. So this is the x value from the vertex here. So negative 3.5 is equal to x1, which we don't know, plus x2, which is 0, divided by 2. Right? We multiply both sides by 2. That gives you negative 7 is equal to, this cancels out like that, so x1, right, that value you were interested in is actually negative 7. Okay? So that would be that would give you a mark. You finding that third point, if I see it on there, quite frankly, you don't necessarily have to do it this way. A lot of students will use the graph. Right, it's like, oh, it takes 3.5, right? It's 3.5 units, because if you think about it, from 0 to negative 3.5, it's 3.5 units. So do another 3.5, you get to negative 7, right? If you go from here, another 3.5 units to the left, it's negative 7. So you don't have to use this, but it's a fail. Like it works every time if you do it right. So then, I didn't give you a lot of room. I understand that. So you kind of, I would like to see this, okay? So in any order, so if you want to go, right, I'm going to go with this, then with the next one, the vertex, and that's negative 2.5, right? And then back to negative 7, and you should see, when you do one of these, you should notice that, right, the y values are the same, meaning that these 2 points are right across from each other, okay? Which is a good sign. You're doing things right. Then you go stat, calc 5, and this is your equation. I'm just going to give you the equation because I will spend more time on the rest. It's 0.5 x squared, and we did expect a positive a value, plus 3.5x plus 3.625. No surprises there, right? We expected the y-intercept. It happens to be the y-intercept that you're given, right? So this is going to give you another mark here. Okay. So if you have the negative 7, if you have that point show up, you get a mark. If you have the equation, you get another mark. If you didn't put keystrokes, take off half, okay? Those darn keystrokes, eh? Yeah. Different? That's fine. That's fine. Yeah. I'm not too picky on how you, as long as you show me, right? I press, this is how I got it, right? Determine the x-intercepts, right? So this one is, don't guess them, right? Like once you have an equation, we base it on this, okay? So I will give you those. Negative 5.740 is one of them, and negative 1.26 is the other. 2 marks for that. I give you 1 mark for each. And of course, if you got the wrong equation up here, this is going to be different, correct? So I go like this and step, because if you show me the keystrokes and then I will go check, right? I have to type this into my calculator, whatever this is for you, right? And check that these are indeed the x-intercepts. So today we're just going to assume you got this wrong, but you got this right, okay? So you don't lose marks here. If I see those x-intercepts, you don't lose marks. Okay, next. Domain and range, your favorite part of the day, right? You loved it in IPR, you love it now, right? So this is technically 0, 0 here, right? So when it comes to time, right? My x values here, I'm going from 0 all the way to 2.758. Okay, so just use the values that are there. And my range is from 0, right? The lowest y value ever is 0, all the way to the highest, which is 2.025. Square bracket, square bracket. So 1 mark for each. And I have to say, even if one of the values is wrong, you don't get the marks there, right? That's how domain and range works. So it's either all in or nothing. So make sure you get that. So it's a little reminder that domain and range is still with us, and this is, in this case, you did not have any infinities. Why? No arrowheads, first of all. Second of all, that you see time and height, right? So there's a context there. And that's that. Okay. There we have another question, and this is type 0. This is what we did yesterday, right? So my x and y values, and I plug this into L1, I plug this into L2. Okay. Determine the quadratic equation. So obviously you would just do the stat calc 5 or quadreg L1, L2, whatever you want to do. And this is the equation you get. (616) 354 x plus 5.995, or if you rounded it to 6, that's fine. The reason why a lot of my keys will have 3 decimals is because some of you do round to 3 decimals. I want to make sure I have that, so I don't need to rerun the whole thing to make sure you round it correctly. So if you put 6 here, that is okay. If you put 3.35, that's okay as well. Okay, so that's your 1 mark, because the points were given. Really, you just had to type it in and go. Initial height of the rocket, depending on your answer here, right? It would be 0.6. So you would have to say 6 feet off the ground, or just 6 feet above ground. Hey, if you said 6 feet, I'm fine with that too. Okay. Or 5.995 if you want to use this value, that's fine as well. Okay. Either one is fine. How long did it take for the rocket to hit the ground? Here's where I'm going to actually, because I suspect that the window was an issue here. So let me turn my calculator on. I've already typed this in before. I'm going to go ahead and turn plot 1 on, yes. Then I'm going to run my quadratic regression. By the way, did you know that you could just run quadreg like that and don't bother with the L1, L2, all of that? The only problem is down the road, okay, we may use values that are in L2 and L3. Okay, so I want you to already learn. I need to tell this regression, quadratic regression, where to get the x and the y values. Okay, and if you just run it like that, it's not going to be in the y1. It's just going to generate the equation, and it's going to be on your home screen, not in y1. Okay, so that's why I kind of prepare you for it already. Okay, so let's do this again. Quadreg, I'm going to call it L1, L2, vars, y vars, enter, enter, enter. And now I can do zoom 9. I don't even hit graph. I go zoom 9 right away, and it looks like a straight line. Some students say it's a linear. No, that's not. You're just very zoomed in. So I'm going to go to my window, and I'm going to look at the negatives. So I don't know, -10. I will increase my x max because I see it that it keeps going to the right. I'm not sure what to do now. I'm just going to go 15. My y min, I'm going to go slightly below, right? And my y max, I'm going to go 3,000 for now. Still not working, not even close, right? So I need to make more changes. But I'm seeing the y axis and the x axis, so I'm happy with that. X max, I don't know, I'm going to go 150. And the y max, I'm going to go 10,000 for now. Overkill, right? But that's okay. You're seeing that. So now you can come back. I'm going to go 5,000 here. And I'm going to slice this in half as well, 75. So that's pretty good. I don't know why that, I'm going to clear that for now. Find the x-intercept, that's what we're after. So it hits the ground right here. So second trace 5. And now you can see that look at my negatives. I'm at negative 14,000. So if I go left with my curve, there it is, comes back up, enter, enter, enter. So we go y2 is equal to 0, second trace 5, and that is 22.99, right, which is approximately 23 seconds. Round. So there you have it. So this page is 1, 2, 3, 4, 5, 9. It's worth 9 marks. Okay, so put a mark out of 9 on this one, and then we'll proceed to the back side. And what I like to see, what I like seeing is pretty much all of you are clicking away. Like it seems like you know what you need to do, or at least you're going to be trying, attempting, right? That's great to see. You know, you're not just sitting there waiting for me to correct this, right? Okay, what's the initial height of the plane? We're given, first of all, let's imagine this thing. It'll be a wide curve. It'll be pointing up, so it'll be something like this, right? And we know that every point represents time and height, right? And we are in feet with the height seconds here, so I'm just going to make a note for myself. There we go. So the initial height is here, right? This is the y-intercept. I just want to make, you don't have to do this necessarily. The y-intercept 0.0, 1.6, right? So 1.6 feet above ground. Why am I making that so complicated? Because I want you to understand, right, what's happening. I could have just said 1.6, and I need you to understand what's happening. It's all flowing. Everything is connected, okay? The minimum height the plane reaches, okay, that's vertex, right? If you ask me. So second trace min, okay? So I'm going to go ahead and how was it finding this? I looked at all your papers had a graph on it, which means I'm pretty sure you know how to find everything. So I'm just going to give you the coordinates of the vertex. This is what you get for your vertex. So the lowest height, right? Lowest height is 0.49 feet. Okay. How long does the plane stay at or below 1 foot? So that's when, right? First of all, at or below 1 foot, right? So you know that y2 is equal to 1 is your go-to, right? And you're going to have to go second trace 5, okay? So what's happening here is if you have a little sketch, right, you will graph the 1 foot mark, and you're going to figure out the start and the end, right? So both of these times are going to be figured out. So watch how the marks are going to be allocated here. To find this first time that I want to see it on there, 1.7876. The second time that happens is 9.3235, right? So you need to figure out, you need to subtract these two to figure out how much time was spent below. So this is not, remember yesterday that crazy example where I found delta time and I took it away from the total? That's only if it had asked how long did it stay at or above 1 foot, right? It's actually, you want to know how much time was spent at or below, right? So delta time is 9.3235 minus 1.7876. So delta time is 7.54 seconds. That's the answer. You subtracting, actually, the province would make that worth 1 mark because you need to understand, oh, okay, I need to subtract. So each of these points is worth half a mark. So half and half, and then you just subtracting, you get another full mark. Yeah. I will say this is how I would mark it, and they are okay with that. If you get the same answer as I do, we won't question it. We're assuming you used 4 decimals minimum. Did you get the same final answer? Yeah, so half off, half a mark off for rounding too soon. RTS is rounding too soon, or RE is rounding early, something like that. We're not going to sweat it, right? Like, if that's the only mistake you guys are making right now, I'm happy, right? If everything else is flowing, you're doing good. Okay, so graph time in seconds. Let's do that right away. And this is height in feet. And I will do this already, so I don't forget. Okay. I need to have my scale here. And this is where you need to think. When you do graphs like these, like, where does the story end, right? And if you read, there's that little sentence, that little statement, right? Right here. I don't know if you read that, sorry, there. The flight stops when Aries catches it at the same height it was thrown. And so the idea here is it starts, so let's make a little sketch here. It starts at a 0, 1.6, right? And it will fly and then it will be caught at the same height. So we need to know, right, 1.6. We need to figure this out. You can use your calculator. You can use axis of symmetry. That whatever works for you. So I'm gonna go find it. Wait a minute. I need to type that in. And I don't have that much time. So sorry guys. If you type this in and then graph your line y2, right? y2 is equal to 1.6. And then you go second trace 5. Okay, you're gonna get this x value, which is, some of you found it, 11.11. Like, it takes 11.11 seconds for this plane to come back to the original. And so this is very important. This is a very important step in order to graph this properly. So I will actually highlight this orange as well, right? Just with that statement up there that it correlates. So I need to make sure I account for that. So 4, 8, 12, 16, that works. Going up by 4, whatever scale you chose, that's fine. I'm getting, I need to make sure 1.6 fits in here because that's the highest you ever get. 1.5, no, 0.5, 1, 1.5 for this mark, 2. That'll work pretty good. And so 1.6 is right about there. 11, so this is 10, so this is 11-ish. You would never think a math teacher would use ish, right, on the statement. But hey, it's always a first time. And then the vertex is 5.56. So this would be 6 is 5. 5.56 right about there. 0.49. Right? So your parabola should look like this. Do I stop there or do I continue? I stop. So that's it. And don't forget your equation. So I will erase that because that was just there to help me remember, and write it in here somewhere. 0.036 t squared minus 0.4 t plus 1.6. So how would I mark this? Well, I would give this, the fact that you found this point here, I would make that worth a whole mark. And then everything else is 2. So I would go with axes labeled, right? Intercepts and vertex. Okay. I need an appropriate scale and equation. Okay, those are the things I'd be looking for. So I'd kind of give each half a mark. Actually, scale is so important that if you get it wrong, actually you lose a full mark for scale. Okay, so scale needs to be done properly, it needs to be consistent. Whatever you choose, go consistent, right? You're going up every 4 boxes, go up every 4 boxes. Don't go 4 then 3, right? Doesn't work that way. Or I'm going to go 2 and then go up by 1. Doesn't work that way. You can have different scales on the axes, but they need to be consistent. Okay, so what are we at here? 3 and 2 is 5, 6, 7. So this page is worth 7. Oh, I know this happens from time to time. So if you went into the negatives here, right, that is a no-no, right? Or if you went past here or went arrowhead, that's a no-no. So take off half a mark today for that. We don't go into the negatives unless there is a very specific statement indicating that, okay? Okay, so add it up. What are we at? 7 and 8, was it? 7 and 9, so it's out of 16. So we leave it out of 16 here. So make sure that it has a mark and your name is on there.